Bismillahirrahmanirrahim. Ahmaduhu wa nusalli ala Muhammad Rasulillahi Kareem. This problem is related to chapter multiple integrals of integral calculus. Show that in the region D, x greater than 1 and equal to 1 but less than e and equal to e. Whereas y greater than equal to 0 and less than equal to natural logarithm x, the following double integration dx cube dA is equal to 3e to the power 4 plus 1 upon 16. We have to prove this. We are given D region, and we start with the left hand side, which is here value of x is from 1 to e. 1 is started from x. In solution we write here x varies from 1 to e and y varies from 0 to natural logarithm x. Here limit of y is variable, whereas limit of x is constant, so we should write this limits first, and so we can find the double integration x cube dA is equal to without any graph we can solve it, because limit is clearly given. Started from 1 to e, which is limit of x, and that of y is 0 to natural logarithm ln or logarithm of x, natural logarithm of x. Here function is given x cube, and dA is write as dx or dy or dy dx according your fashion, because there are many books and writer which use these different values. In engineering mostly this for this integration variable is right here, so I because it is it is for variable y, so I write dy here, and for this I write here. Now if you write like this, then you have to integrate y first, and you should write this integration as x equal to 1 to e, and for y x is constant, so take out x cube from this sign of integration, and let here 1, because x cube into 1 is x cube, so write x cube here, because this passes through this integration, which is integration of y. So x is constant, so take out x cube here, and only you have to integrate 1 with respect to y. The integration of 1 with respect to y is integration of 1 is with respect to y is y, so I write here only y. What limit is given? Y is equal to 0 to natural logarithm of x. We will get this as function of x, and then we finally integrate with respect to x. Write upper limit upper limit minus lower limit. I write low upper limit in place of y log x and minus log, put the value of y here in place of y, which is lower limit 0, and now integrate with respect to x whole value, and we can write it as x equal to 1 to e x cube. You can write log and x minus 0 is log ln x is equal to minus 0 is equal to and then x is natural logarithm x. You can write it as a log of x. You have to integrate this, and here this is a logarithmic function and algebraic function. Using ILAT, you should consider log first function and this is second function, and apply this formula of integration. Integrate first function as it integration of second function minus differentiation of first function and integration of second function, and integration of whole this algebraic function. Is making consider first function using ILAT rule. So first function as it according to this formula, first function as it integration of second, integration of x cube is x to the power 4 upon 4, because one power is increased, and also divide same 4, and apply limit x equal to 1 to e minus, that is second term, and applies sign of integration. Differentiation of first, we know that differentiation of log x is 1 upon x, and integration of second, which I write here, which is x to the power 4 upon 4, and now integration whole value with respect to x from limit x equal to 1 to e. Now we should write this value first, so we can write 1 by 4 x to the power 4. This is first term, 1 by 4 x to the power 4 log x, limit is x equal to 1 to e, minus you can take out 1 by 4 from this sign of integration, and 1 power of x cancel by this x cancel, only here becomes 3 power, and minus 1 by 4 constant is taken out from sign of integration, only x to the power 3 is remaining term here, and limit of x equal to 1 to e. You can put the value of upper limit and lower limit. First you put the value of upper limit, which is x is equal to e, so you write e in place of x. We get this value, upper limit minus lower limit. For this you should put the value of x equal to 1 in place of x, so I write upper limit minus lower limit. This term completed here. Minus now integrate this value, so it becomes x power of x 4 upon 4, and integrate this value from 1 to e. We know that if there is no written base, then we know that then it is e. When these values are equal, then we know that it becomes 1. We know that log m base m equal to 1, so you can write this value is 1, minus this value log 1. We know that log 1 is equal to 0, so you can put the 0 because this value is 0 multiplied with this becomes 0, minus 1 upon 4. Take 1 by 4 from this bracket and apply upper limit minus lower limit. Put the value of x is equal to e in place of x for upper limit minus for lower limit put x equal to 1. Here x power is 4, so I write 1 to the power 4. Here 1 by 4 e to the power 4 minus 1 into 1 1 or 4 into 4 16 e to the power 4 minus 1 to the power 4 is 1. On open this bracket, we can write it as 1 upon 16 e to the power 4. This sign changes, this minus sign, so it becomes 1 upon 16 into 1. Now you can take 16 as a LCM, and on dividing it becomes we get 4, and multiply the numerator, we get 4 e to the power 4 minus when divided by 16 we get 1 multiply to this, we get e to the power 4 plus like this we get in numerator 1. This value is on solving 3 e to the power 4 plus 1 upon 16 which was to be proved. Thank you very much indeed for listening me. Wa akhir da'wana alhamdulillahi rabbil alamin.